Yeah, it's my pleasure to introduce and welcome Dr. Tiffany Timbers. Tiffany is an assistant professor of teaching in the Department of Statistics and a co-director of the Master of Data Science program at UBC. In these roles, she teaches and develops curriculum around the responsible application of data science to solve real-world problems. One of her favorite courses she teaches is a graduate course on collaborative software development, which focuses on teaching how to create R and Python packages using modern tools and workflows. So I personally admired Tiffany as an educator when I first joined the Carpenters organization a few years ago. And I was super excited to find out that she was located in Vancouver when I moved here. So thank you so much, Tiffany, for agreeing to teach this workshop. So yeah, please take it away.
Awesome. Thank you so much for the introduction, and thank you so much to the organizers for running the meetings, keeping this organization and chapter of Our Ladies going, and for inviting me. I've had the pleasure of attending some Our Ladies talks previously for Vancouver, as well as given, I think, one in the past, and I've always had a really great time. And although I do teach R, I'm still an avid R learner. And so yeah, I see this as like, I'm not the instructor today, I'm just showing you a little bit of something that is useful, and I probably will learn something. I do every time I teach, and hopefully you folks learn some things too. So yeah, I think I'll start with sharing my screen at this point now. So let's do that. Let's make sure I'm sharing the right screen. And I will probably pin my video, I guess. So it's just like my head and not everybody else's head, so it takes up less screen space, if that's okay with folks. Just my standard teaching setup. Been teaching a lot on Zoom this year. Okay, so this Our Ladies session is about how can you do some programming with the Tidyverse functions. And what do I mean by programming? I mean by starting to abstract your code into functions, as opposed to just calling functions one after each other inside of your R Markdown document or inside of your script. And things get a little bit tricky when you start programming with the Tidyverse functions at first, and I'll give a little demonstration of what that trickiness looks like, and then hopefully explain at a high level why that's a little tricky, and then most important, give you some solutions on how to solve that. So what I put together here is a little GitHub repository. You don't need to know how to use GitHub to get access to the materials. You can click this green button and then click download zip. And then that should download all the files and folders on this GitHub repository to your computer or laptop, and you should be able to open them up inside of RStudio. And so there was some kind of prerequisite knowledge for this workshop. So the prerequisite knowledge is that you've used 2 to 3 Tidyverse functions and you know how to write a function in R. I will go over how to write a function in R very briefly, but it will be helpful if you've seen these things before. And I'm going to be using RStudio and assume that end-to-end R, and assume that you have some basic understanding of those things as well. And if you don't, that's also fine. You are very welcome here. Just enjoy the ride, and you feel welcome to just watch the workshop as opposed to code along. All right, so I am now going to move into RStudio. So what I have open here is a copy of, but you would be working, because I've removed some things because I'm going to do some live coding as we go, because it helps slow me down, of the prog-tidyverse-functions.rmd in that GitHub repository that you are welcome to open up and run the code alongside with me. So the first thing I want to do when I get started is make an attribution to where a lot of the materials came from. So a big part of this R Markdown document was derived from the Programming with Ggplot vignette by Hadley Wickham, Romain Francois, Lionel Henry, Kirill Muller, and RStudio. And the rest was derived from some of my teaching materials in MDS, which is heavily derived from Hadley Wickham's Advanced R book. So let's get into the topic for today, which is programming with the Tidyverse. So most of the Tidyverse verbs, or we'll call them functions here, use something that's called tidy evaluation in some way. Tidy evaluation doesn't have to mean anything to you yet. We're going to work our ways up to it. What can we start to say about tidy evaluation? Well, it's a special kind of non-standard evaluation that's used throughout the Tidyverse, and it will become clear as we go through examples, but I'm just going to give you two kind of different contexts that you'll see it in. So one of them is when you're one context is data masking, and you're going to encounter that even if you don't know that you're encountering it. You are encountering it when you're using some dplyr functions like arrange, count, filter, group by, mutate, and summarize. Okay, and what at a very high level data masking is it's allowing you to use data variables, which we can think of as the columns in your data frame, as if they were variables in your environment, like the data frame itself or a character vector that you've created. And then the other context that you will see tidy evaluation used in is called tidy selection. And the kinds of dplyr, just some examples of some dplyr verbs or functions that you would see that being used in is across, relocate, rename, select, pull. One thing to notice if you're familiar with these functions is that they're all functions that really operate on columns in the data frame. And this tidy selection allows you to choose variables based on their position, either numerically or using their names, okay? And how do you know if it's not one of the ones that I've listed here, or if you forget what I'm saying today, which is very likely, and you go to your notebook and you're starting to be working with the Tidyverse and you want to write some functions? Are you working with a data masking function or a tidy select function? What you can do is look in the documentation, and the documentation for these functions should clearly say which of the two they are. So they'll have something like data masking here or tidy select when you look in the documentation. So if we open up the dplyr arrange docs, if we scroll down, we can see here that it is a data masking function. And then if we go over and look at rename, and we scroll down, we can see here that it's a tidy select function. So this is something that you will want to know and investigate when it becomes time to wrap your Tidyverse code, Tidyverse function using code into a function. Okay, so what does this all, I think I may have skipped over some critical thing. What am I really talking about here? So what I'm really talking about here that's a bit cool and interesting with the Tidyverse functions is that you can use them by referring to the column names in the data frame without using quotations around them. And if you've been using R in an interactive manner for a long time, that you probably don't even think that that's weird anymore. You're like, yeah, of course you can do it. But it is a little weird. Many or most programming languages don't let you do this. And the way, and there's actually a lot going on behind the hood that allows you to do this in R, and it is a little special. And one of the reasons that these functions have been made this way is that they were really designed for analysts who are creating visualizations, doing statistics on data, and they're going to be, working in the world of the data frame. And by allowing these analysts to refer to column names without putting quotations around them, there's less typing to do. And so your programming can become faster and more fluid and really nice. However, because there's this extra complexity going on that you're not initially aware of, when you go to use them in an abstract manner, in an indirect way, like in a loop or a function, this can become problematic and challenging if you're not aware of it. And then even if you are aware of it, how do you solve it? So what we're going to be talking about at a very high level, why is this going on? And then how can we get around that? Because that's mostly, at least what I care about when I'm writing my analysis code. So let's get started. Oh, and the one other thing I wanted to say is that this is a very deep topic and we are just going to be touching the surface of it. So the dplyr vignette has more information. I've kind of stripped some of it away from there. So I would recommend that that's the place you go next if you want to learn more. And then if you want to go further, there are some chapters called meta programming in advanced R, and tidy evaluation kind of falls under that larger umbrella. And so that's where you'd want to go to get a deeper understanding of this. So let's get set up for today. So in this, our Markdown document that I'm going to be walking through, the only thing that we need is the Tidyverse library loaded. So I'm going to run this cell. And I've given in the Markdown document message equals false, so we don't get that really big printout from loading the Tidyverse like we usually do. So before we get going, what I want to just remind all of us, because maybe it's been a while since you've written a function, or you've heard about functions, you've seen somebody else write it, but you haven't written one yourself, but you're aware of them. What does a function look like in R? So in R, we define a function and name it using this very general syntax, okay? So here it says variable. So like that's the name that you're going to give to the function. You would put something meaningful there. And then this is the special word function in R that says this kind of thing is going to be a function. And then this is where we put in our function arguments. So this is these are going to be variables that are going to be used within the function body to do things. And then you fill in the body of your function code here between curly braces. If you write the function all in one line, the curly braces are not required. But if you have, most functions have multiple lines of code. And so when we do that, we use these braces to tell R that the body of the function is going to start at this open brace and then end at this closed brace. So I'm going to just give an example of writing a really simple function here that's called add, and it's going to add together two numbers. So we're going to say add. I'm going to use the assignment symbol. I'm going to use the special function word. And this function is going to take in two arguments, X and Y. And these are going to be the variables that hold the numbers that I want to add together within the function. Then I'm going to use the curly braces so that I can spread this across multiple lines. This is a simple function I don't need to, but I usually will write multi-line functions. So it's just something that I'm habitually do now. And I'll do X plus Y. And that is my function. That's all I need to do. In R, you don't have to write return at the end of a function. And stylistically, at least the Tidyverse style is to not use return unless you do an early return in a function from some sort of conditional. But we could have done something like this, Z equals X plus Y, and then we're going to return Z. So that is also acceptable syntax. But I'm going to go back to how we stylistically typically do it without using a return statement. Okay, so now we have defined and named a function called add. Now that it's named, later on in our notebook, which is now, we can call this function by name and pass it arguments. So here we're going to say the function name, and then we're going to say X is going to hold the value 5 when we run the function this time, and Y is going to hold the value 10. So if we run this, we'll get the expected answer of 15 out of this. So this is just our little reminder of what functions in R are and how we can use them. Now, this was a very simple function and probably seems, a little bit unneeded. Just adding 5 and 10 could be done with the plus operator in R. But I wanted to have a toy example just to make it crystal clear. What would a function look like that we might actually need in our data analysis? Well, how about something like this? I'm going to type it out. Sorry, I have some leftover code in here. So what if we wanted a function where the user passes the function a data frame, and this function groups the data frame by a user specified column, and then calculates the mean for each group of another user specified column. So let's do that. So we're going to create this function. We're going to call it group means. And we're going to use that special function word again. And then we're going to say that it's going to take data frames, and we're going to call that data. And then we're going to take in a column that we're going to group by. So we're going to call this grouping column. And I'm going to have a column that we're going to summarize. We're going to take the mean of. So column to summarize. Okay, and then we're going to use the curly braces here because we're going to split this across multiple rows. So I'm going to have data, and I'm going to send that into group by. And then I am going to group by the grouping column. And then I'm going to pipe that into summarize. And I'm going to make a new column called column mean in summarize, and it's going to be the mean of the column to summarize. Right here. Okay, so this is the function that I'm going to define. And it's it's something that you might repeatedly do over and over and over again in your analysis, right? Data group by summarize, data group by summarize, data group by summarize. So perhaps by defining this function, I can save a little bit of typing. So let's define this function and let's ask, will it work now? Okay, it's kind of the big question that we're asking today in this talk. So let's look at a built-in data frame from the Tidyverse meta package, the Star Wars data frame. And in this data frame, we have height and yeah, let's focus on height. So can we use this function to get the mean height for the different species? Okay, so we have later on here, we have the species from the characters in the Star Wars data frame. So we're going to say, can we use our function to get the mean height for each of the different species in the Star Wars data frame? So let's go through how we would do this to prove that this is possible using the Tidyverse without our function. So we would take the Star Wars data frame, and then we would pipe it into group by and we're going to group by the species column. And then we would go into summarize, and we want to again come up with this column mean, and we're going to take the mean height. Okay, so let's hope this works, and it does seem to work. So what we get back is a special kind of data frame at Sybil that is 38 rows and has the 2 columns. And we have each of the species in the Star Wars data frame and the mean height for each of those. Okay, so we know that this is now possible with the Tidyverse. Is again coming back to this question, is it going to work for our function? So how can we do this? Well, we'll call our function. So we define this function that was called group means, and it takes a data frame. So let's give it the Star Wars data frame. And then it takes the grouping column, which is species, and then it takes the column that we want to calculate the mean for, which is height. Let's see what happens. And we get this error that says must group by variables found in .data. The column grouping column is not found. So it's throwing an error when it's trying to handle this, which is the second line of our function when we're doing the group by. So this won't work. And what the problem is here is this unquoted variable name here. R doesn't know what this is right now. I mean, if I just, let's comment this out. And so I'm going to run R in the global environment, and I can type Star Wars. Okay. And if I run that, it knows what Star Wars is. But if I run height, it doesn't, oopsies. Let's make sure it's rerunning it. It doesn't know what that is. Outside of the context of the data frame, height isn't a variable. Height's really only a variable within the data frame. Okay, so that's what's going wrong here. And we'll talk a little bit more using some more formal technology or formal terminology about what exactly is going on here. So I'm just going to look at the participants panel. Can I get a thumbs up if folks are following so far? Any questions? I can pause in the chat and see if there's anything. Okay, seeing some thumbs up, so some folks are awake and listening. It's great. So I'm going to go on now to talk about the first of these 2 contexts that tidy evaluation would work. And
Tiffany,
yeah,
we have one question.
Perfect.
So the question is, would data $height work instead of just height?
Right here when we're calling our function.
I think so.
Yes, I don't think it will, but we can give it a try. So we can say data $height and data, species and height. And that's not exactly going to work because it doesn't know. So we don't have a data frame here called data, and we're using this operator, oopsies, to go look for it. So this isn't going to solve our problem either, but it's a good guess. And I don't think you're going in the wrong direction. Another question, would Star Wars, if we explicitly point to this, will this work? And I actually don't know the answer to that either, but it's not going to work. And I think the reason that that's not going to work is that when we go into our function, group by is used to taking just the unquoted column name. That's what group by was written to take. It wasn't written to take a vector, essentially. So it's looking for a column. I know a column of a data frame is a vector, but it has to be inside of that context. So again, it's a byproduct of how these functions were written. And again, they were written with this with the primary use of being this kind of interactive data analysis. But people, once you've been using them for a long time for that and you want to start abstracting your code, it feels very natural to want to write your code, continue to write your code where you're using functions with the Tidyverse. And so that's where we're going with this. So, okay, let's talk about what's going on here. So what's happening in group by, for example, is that it is able to look up and see, it's able to see that and understand that column height, for example, or species, I think we were talking about, because group by is being evaluated what's called the data mask, okay? So the data frame is thought to mask the global environment. So R is going to look in the closest environment. That's how R essentially works. When it looks upwards for variables and functions, it looks in the closest environment first. And if it's not there, then it goes up and looks at the next level, okay? And if we don't use the base R strategy for dealing with this is that we have to point directly to this context. So here we're doing some base R filtering from the Star Wars data frame. And then we're saying we want to look where the home world is equal to Naboo. And so to reference home world, or to have R know where home world is, we're using this $ operator to point directly at the data frame where R should be looking, which environment R should be looking for home world. And then the same thing's happening because we're saying when this filtering is when the home world is Naboo and the species is human. So this $ is connecting species with Star Wars. And this works. So we can take a look at this here. We get a data frame, we get what we want back. But it's very redundant typing, right? So how many times do we see Star Wars show up in this line of code for filtering? We see it 1, 2, 3 times. And if we filtered on more things, then we would get an additional Star Wars $ for each other thing that we want to filter on. So the dplyr or Tidyverse equivalent of the code is more concise because these functions are written so that you open up the data mask and you can evaluate the data variables inside of these, okay? So here we're having the Star Wars data frame piped into filter, but maybe it's a little bit clearer to make this very clear. So we can say Star Wars. So the data frame is always the first argument for the Tidyverse functions. And then here we can, because filter, all of these function arguments are going to get run and evaluated in the data mask, we can use the unquoted column names here because it's going to look there first and it can see that, okay, inside of Star Wars, there is something called homeworld. Inside of Star Wars, there is something called species. And then it can evaluate it that way. So we get very much the same answer. I know there's a difference in the number of rows, and the difference comes from the base R returning the NAs, where that is not what happens in the filter function. Okay. So let's talk a little bit more about this and more formally define these different types of variables. So we have in R these data variables and these env or environment variables. And the key idea behind data masking is that it blurs the line between the two different meanings of the word variable. So these environment variables, again, are programming variables that live in an environment that you usually create with the assignment symbol. And so one of them, for example, is like the Star Wars data frame. Or if I was to, so here is another example of one, DF. DF exists in the global environment, and it's an environment variable. And these data variables that the tidy evaluation is using within the data mask is, these are statistical variables that live in a data frame. So they're like they're essentially the columns in your data frame. And you usually create them by reading in a CSV file or manipulating existing variables. So let's use these labels now to actually label this code here. So here, df, on the left-hand side of the assignment symbol, this is going to be an environment variable that exists in our global environment. Then we're using the function data.frame to create a data frame that has two columns. They're named X and Y. And X here is a data variable, and Y here is a data variable. So let's take a look. Maybe I'll output both df and dfx. So if we take a look at the data frame, so df is the environment variable, and then X here, this is a statistical or a data variable. Y here is a statistical or a data variable. And when you try in your R code to reference these things outside of the data mask, outside of the data frame, R doesn't know what they are, and then that's where you get into trouble. Okay, so that's the idea behind what is going on. So essentially what I want to say again is that it's a beautiful feature of Tidyverse programming that, or Tidyverse syntax, that in this interactive programming land, when you're typing things into the R console, or you're working in an R Markdown document or a script where you're not using functions, this all just works really well. But when you start to wrap this in functions, this is where we get into trouble. So now we're going to talk about this trouble, okay, that I've already illustrated earlier. So the main challenge that you're going to run into, as I alluded to earlier, is when you're writing functions. And so the thing that you need to do to deal with that is add some special operators that essentially tell the function that this variable, the thing that we're trying to reference, should be evaluated in the data mask. And the special syntax for that is 2 braces on the left-hand side and 2 braces on the right-hand side. So these are called curly curlies, which is a nice, cute name for this operator. And you can think another way to describe this is you embrace the column name or embrace the arguments that you're using in your function. So this is the exact same function that we saw before. So this is our group means function. Again, it takes in a data frame. It takes in a column that we're going to group by, and then it takes in the column that we're going to summarize, which is going to be taking the mean. And the only thing that I've done to change this is to add the curly curlies and embrace the function arguments. So let's redefine our function with the embracing of the function of the columns, column names, or the function arguments that are referring to the column names, and try and use our function now. And now we see we get what we wanted. We get not an error. We get a summarized data frame that has the species that we grouped by and the mean height for each of those species. Okay. Does anyone, I'll pause here and see if there's any questions that people might want to ask.
I'll ask a kind of a very simple question, actually. So I noticed stylistically there's a lot of spaces in between the embrace. Is that required or?
No, it's not required at all. You can definitely do this, but it gets, for me, at least a little hard on the eyeballs. This makes it a lot easier for me to read. Yeah.
Thank you.
Yeah, I actually have a question as well. So if, since this embracing with the curly curlies only work when it's given a data frame, if we move those curly curlies to that line, the first line with the function, I'm guessing it won't work there.
No, exactly. So what's happening inside of here, so there's some more complicated things that I'm not going to get into that involve something that's called quoting and unquoting. And the problem is that when we're calling this species, okay, so when we're calling, so okay, let's talk about this. So what's going to happen? Group means get called, and it is going to hear and go and look at the first argument. It's like, okay, I need to find what data is. Data, it's going to look up, data was in the first argument, and then it's going to look into the global environment for data. Okay, and that's fine. Star Wars, it works. But then what happens is that it gets to this second argument here, if we weren't using the bracing, and it's going to look for grouping column to be pointing to something that exists in the global environment, but it doesn't, but species doesn't exist in the global environment, right? So it can't find it. So that's where the, so essentially what has to happen, there's another way to solve this problem, which is through something that's called quoting and unquoting. And so here, we would have to use something that's like nquo, and you would apply that to the grouping column. If I'm going a little off script here, but it might make the explanation a little easier. And so here we're quoting it, so basically putting quotations around it. And then here we would be using another operator, I think it's bang bang, that would do the unquoting and basically like stitch the word species into this into the code here, and then the code could be run and work. So in the background, there is this more complex thing happening, but for you at this first level of like having to deal with the problem, all you need to remember, oopsies, is that there is this problem because of the unquoted column names with indirection, and the easiest way to solve this is using this curly curly operator. Does that somewhat answer your question?
Yeah, that makes sense. I was trying to think of a way to use bang bang in part of this. So yeah, that completely answered it. Thanks.
Okay, great. Okay, so there's another way that you might want to deal with column names when you're programming, and you might want to use them as a character vector, maybe like quoting them, calling them species. So if we, again, didn't do something about this, this is going to be a problem, because the group by function and then later the summarize function, they don't want character values, they want that vector from your data frame. But this is a very reasonable way to pass around information in a programming sense. So how can we handle it? So when you're in the situation where you want to use quoted column names with your functions, instead of using the curly curly braces, what we'll do instead is use the .data pronoun and then square brackets and put the column name that you're trying to access inside of here. Okay, so it's important to note that .data isn't a data frame, it's a special construct that allows you to access current variables either with .datax or indirectly with .data and then putting the column name inside of it. And this is a Tidyverse thing, and you shouldn't be expecting this to kind of work outside of the Tidyverse from my understanding, okay? So .data, using that special data pronoun, and then these double square brackets will let you refer to, would let you have your function designed to take in quoted art, like think of like essentially character vectors, and solve the problem that way. So I'll just prove that this works by running both of these, and I don't know why it's doing this in my apologies for that weird auto scrolling it just did. But here we go. We have, oops, that's not that one. Right, here we go. We've used the quoted quoted column names using this .data pronoun with the double square braces. And kind of like when might you decide to do this? I've seen it used primarily in the context of dashboards when you're having like interactivity, and just some of the dashboarding tools seem to be a little bit more preferring this, or it just seems a little bit more natural to use quoted column names for what you're doing. But outside of that context, this first strategy of using the curly braces is more of what I've seen and more of what I've used. Okay. So I'll pause here before I move on to tidy selection. So does anyone have any questions about the kind of data masking before we go on to what tidy select is?
Feel free to put it in the chat as well. Oh, there we go.
Right, and so
can you explain? Yeah.
Yeah, sorry, I can read it as well. So Anar is asking, and the reason group by with quotations, grouping column won't work is because essentially group by wasn't designed. Group by could have been designed to work with that, but it wasn't. Group by has been designed to work with unquoted column names. There used to be, I can't remember how many years ago, maybe 5 years ago, parallel versions of almost all of the Tidyverse functions. So there used to be a group by, oops, that worked like this. And then you put some sort of grouping column in here. But that meant that the Tidyverse team would have had to do a lot of maintenance, right? Like you essentially have to, maybe it still actually exists in R, but it's being deprecated. So these were written to work with strings as the column names. But this is being not the preferred way to do things. And I don't think that there's going to be long-term support for this method. And instead, they're coming up with these more kind of like universal solutions to work with all of the Tidyverse functions using either the data pronoun or the curly braces. Great question. It's really interesting in programming that like almost anything can be possible. It's like choices that humans make when they're writing these things that limit how things will work without great effort. Okay, so next we're going to talk about tidy select. So data masking makes it easy to compute on values within a data set. Tidy select is it's not the same thing, it's a little bit different, but it's complementary, and it's working with the columns of a data set. So think about the dplyr functions or other Tidyverse functions where that function is specifically just working on columns, like renaming them, selecting them, those sorts of things, moving them around. And basically there is this package that we're just going to go at a high level of what's happening here. There's this package called tidy select, and it basically provides the ability for functions like select to work like this. So with select, you can do things like select df being the data frame, and one is going to select the first column. You could also use select df / and then with this last column function to grab the last column. You can use select df, and then you can use unquoted column names inside of a vector to select columns A, B, and C. You can also use partial string matching, so columns that start with A or columns that end with Z. And you can use this where function where there's some sort of conditional attached to it. So where an example here is where is numeric. And all of these features come from this tidy select package. Okay, so what it does is it gives us this amazing toolkit for interactive data analysis, again, where we can do like from another programming language, this thing, like what you're doing here is like not at all common and would blow a lot of other people who commonly program in other languages, blow their mind a little bit. It's very cool, again, for this interactive programming, but when you want to do things like that use interaction, again, like writing functions, is where we're going to have these challenges. So what I'm going to show you now is how we can solve these challenges. So I am going to do a little bit of live coding again here, where we're going to create a different function, and we're going to create to demonstrate what I'm talking about here a little bit more. So we're going to create a function that's called rectangle. And this function is going to be a subsetting function, okay? So what I mean by subset, it's going to take a data frame and it's going to select, or it's going to, sorry, select. It's going to take a data frame and it's going to get a subsection of it. So a certain number of rows, like rows 5 to 10, and columns, we could use them. It's going to be able to use the numbers, or it's going to be able to use the column names, okay? So that's how I want to make this function. So again, we're going to use the special function word. It's going to take in a data frame. I'm going to call that argument data. It's going to take some span of columns. It's going to take advantage of that tidy select. And then I'm going to take advantage of the slice function in the tidyverse to say what the row starts at and what the row ends at. Okay, so that is how I'm going to do this. So I'm going to take data, I'm going to pipe it into select. And here is where I would put columns. And then I'm going to pipe it into slice. And slice can take a range of rows. So I'm going to say row start, and it uses a colon to say what like basically make a sequence from 1 to, or whatever the start is to the end is, and then take those rows from the data frame. Row end. So just going to pay attention to the chat here. Who thinks, or let's do the vote on the participants panel. Thinking about what we've learned so far, who thinks that this is going to work? Put your thumbs up if you think it's going to work, or a thumbs down or a red X if you think it's not going to work. Right, we're getting most people saying it's not going to work, a few people thinking that it's going to work. And hopefully I've been saying enough about the challenges of unquoted column names. This is going to have the same sort of problem, I think. So what we can do instead is we can put the curly braces around it. Well, let's prove that it's a problem first. I don't want to mislead you here. So let's try, oh, this isn't giving me a problem. So maybe I am going, leading you a little astray here. Let me try and call that function first and see if it actually works. Let's see, let's do rectangle. And Star Wars, and let's try height. Well, let me define it. I haven't actually used it, so maybe I am. Let's try this. We'll do Star Wars, and we're going to grab the columns from eye color, and we're going to go from rows 1 to 5. Okay, so what's going to happen here is Star Wars is going to be the data. We're saying grab the columns from height to eye color and start the first row and go to the 5th row. And it's doing this weird scrolling thing. So let's go back, please. And actually, we are getting a problem. Okay, I was a little worrying that my demo wasn't going to work, but yes, it's going to let me define the function. But when I actually go and call the function, it's not going to work. And the reason it's not going to work again is this unquoted column names. So what I'm going to do again is reach for my embrace strategy to try and solve this problem. So if I embrace the columns, hopefully now, and I don't know why sorry, this is a new kind of rendered R Markdown, like interactive rendered R Markdown, and maybe I need to update to the newer version of it. We can see that it does work, okay? So when we are using functions that use tidy select and we want to use unquoted column names, we can use that same strategy of embracing the column names, the arguments for our column names inside of the function to let this work. Okay, now what if, again, you want to have this strategy where you want to pass in a character vector instead of these unquoted column names. Again, it's a very reasonable thing to do in programming. Like we want to say rectangle, Star Wars, and then either have vars, or we could even just like, maybe this will be more explicit, or I'm going to just drop this in here. We want to do this instead. How can we make that work with tidy select? Well, with tidy select, we have some special helper functions that we can take advantage of that will let us do this. So if we say all of, and then we pass it a character vector here for whatever columns is going to be, that is going to be okay. So this can work. So if we run this, really sorry about it keep going up and down like that. We can see that we are able to get the columns that we wanted, which was height and mass, for those first 5 rows, okay? So olive is one of them. We can also pass it a character vector and say any of these, so it does some sort of partial matching. And if you want to exclude anything, so maybe we want all of the columns except for height and mass, we could put the basically the bang in front of it, the not operator, and that would give us back the columns that don't match the ones coming into the function argument. Okay, so I've just said a lot there. I'm just going to pause again and see if there's any more questions.
I guess for me, I just don't get when you choose which way to go with when you're like how you write your function.
Yeah, that's a great question. Because both are valid choices, it is going to be left up to you. And I would say I would usually pick the unquoted just because that's how I'm used to using the Tidyverse functions. And so if I'm going to be wrapping them up, then I'm typically going to be using them in a similar way. But if there's some other process kind of like feeding into your function or going to be calling your function that is going to be more naturally like generating character vectors, then that's when you're going to want to go for this. Okay, so like if you have, I don't know, another data file that has like your function is going to be, you have 2 maybe data frames, right? One that you're going to be calling your function on, and then this other data frame that has a character vector that refers to the column names in this data frame. If you have something like this, then using a character vector is probably a more natural approach for a function like that. Does that make sense?
Yeah, it does. Thanks.
Okay, so maybe because I'm going to be switching topics to talking about another operator, the Walrus operator, do we want to take our break now?
Yeah, that sounds good.
Okay.
Should we say a 10-minute break for everyone? Would that be enough? Yep. Okay, so let's come back here at 7:04. Right.
Not very, it's almost completely absent, for example, from Python. However, in the pandas library, there is an example of it, of doing this sort of like lazy evaluation, like delaying evaluation, and using kind of like unquoted column names in the with the query method. So it's kind of interesting that like in this data analysis context, I think it is very useful for drawing out your code. And so I do think there's more reason to do this more than just for interactive programming, but it adds this extra layer of complexity for sure.
Yeah, I think it's hard to encounter it until you are faced with the problem of trying to, I guess, even just tidy evals and quotations and unquoting, and you don't really know about it until you hit the problem, and then you just go into the deep webs and try to find someone with the right, code to copy from on Stack Overflow or something like that.
Yeah, and I think that like people who teach or use base R don't hit this problem because they don't touch the tidyverse. And then you can actually get really far with the tidyverse before you need to like write a function yourself, or, and even like, many data science educators that know base R and know the tidyverse are kind of like, oh, I know that there's this problem, but I'm not, exactly sure what the solution for is, or how effective I will be at teaching why that there's a problem in the solution. But yeah, the documentation and the tools for solving this from the Tidyverse team is getting a lot better and helping a lot more. So I think that this will be seen more widely used, and in the future. Okay, shall I keep going? Okay, So let me make sure I'm sharing the right screen again. I'm back here. I can only see my video, so I think everything still is the same. So we're going to go on to another thing that you might want to know about if you're doing programming with the Tidyverse, because when you start to use things like mutate and summarize, and you want to use a column name that goes on the left-hand side of the operator, of the equal sign operator, you're going to see that it doesn't work. And I'm going to demonstrate that for you here and try again a little bit to explain maybe what's going on, a little bit of what's hinting at a little bit of what's going on behind the scenes, and then most importantly, how to fix it. So this is the operator I'm talking about. It's got its cute name. It's called the Walrus, and you can kind of maybe imagine why. Like those are two eyes and two tusks. It's like turned on its head. So that's the Walrus operator, and we need it, as I just kind of hinted at, in some cases when we're assigning values with tidy evaluation. So for example, if we wanted to take this group mean function that we wrote earlier and improve it so that the column name in the summarized data frame was the column name from the original data frame. So again, this was our group. This is our group means function, and I've added something to it, but I'll just refresh our mind. So it's called group means. It's a function, takes in a data frame, it takes in a grouping column, and then it takes in the column to summarize, which we're going to summarize by getting the mean. So we take data, we're going to pipe it to group by, and it's going to group based on the grouping column, where we've dealt with our unquoted column names by embracing them. And then this is the same as last time too. We're still taking the mean of the column to summarize, but the new thing here is that we want to take that column name, whatever it was, if it was height or if it was mass, and that's what we actually want to call it in the summarized data frame as well. And so, well, let's deal with it in the same way. Let's add those curly braces and let's see if this works. But we can't actually even define this function. We've never even encountered a problem like this before. Before we could at least define the function, and when we ran it is when we came into a problem, but here we can't even define it. So what's going on? Well, what is going on is that, as I alluded to a little bit earlier, it's more complex than we're being allowed, than I can fully explain here, or even myself fully explain, but there's some stitching together of code that's happening. And it's not correctly, from my understanding, being stitched together here. And so what we need to do is to use this special operator that's going to allow the correct surgery to be done so that we can put we can indirect to a column name on the left-hand side of the operator. That's the depth that I can fully explain this at. And again, you probably have to dig into the advanced R book, for example, to yourself in the meta programming chapter to go further than that. So once we add this Walrus operator here, then we can actually define our function. So we don't have that problem anymore, and then we can use it. So what's going to happen this time when we summarize it is, you can see, instead of this being called column underscore mean, which we had used before, it's the column name height has been able to be indirected into the summarize function on the left-hand side of the assignment symbol, or now the more specialized Walrus operator, and we can actually put that there. This is also, what other functions will this come up with? So another function that you'll come up with this where you're using the equal sign is going to be the mutate function. So again, if you were going to do some sort of indirection with column names on the left-hand side of the mutate function, that's the other case when you would have to use the mutate operator. So kind of that's the take-home message. When you're creating or overwriting column names using tidy evaluation, and you want to do indirection with unquoted column names on the left-hand side, that's when the Walrus operator is your friend. Now, there's something that's pretty cool here, is we can go even further and use the glue package, which is related to what we're doing here. And we can stitch together a string with the column name that's being indirected. So here, what we're gonna end up having a column name that is gonna be mean underscore whatever column name gets put in here, which is pretty neat and pretty cool. So let's define this function and run it here. And so you can see here, it's not the best output with this rendered our Markdown output, but it's going to be mean underscore height. So it is essentially taking this string and then adding that or concatenating that onto whatever the indirected column name is here. And again, that kind of correct blueprint stitching of code is going to be requiring this special Walrus operator. So I can stop and see if there's any questions. Again, my telling you kind of like the context that you want to use this and how to use it is more of my strength in answering the questions. I'll do my best if you have some more deeper questions.
So that last one is blowing my mind a little bit. I don't understand why it's able to understand that it's not character there.
Yeah, to be honest, that is a bit outside of my depth as well. So this is something that I learned from reading the Ggplot vignette for programming with Ggplot, but I haven't had time yet to kind of dig. And in that vignette, they say it's using some of the features of Glue to do that. So Glue is a package that's useful for stitching. I think, from my understanding, like templated code or code together, but using this kind of string notation, and these kind of special braces are heavily used in Glue as well.
Cool. I'll have to try play around with it. Thanks.
Yeah, no problem. I thought it was in there and it's cool, so I'll show it, but I don't have a deep understanding of it. Okay, so the last thing that I'm going to do before we kind of shift over to seeing if we can work on the worksheet a little bit is to show you that this works for more than the Ggplot packages. So the only functions that I've been working with have been like select and group by and summarize, like this very standard Ggplot ones, but really I wouldn't necessarily guarantee all, but many of the Tidyverse package functions that use unquoted column names should work with tidy evaluation. So here's another example. One is from Ggplot, and that's actually a really great function that we often might want to write into. Ggplot is Ggplot and the Ggplot functions are great functions that we often want to abstract into another function, because some of your plots can get really big and you can make maybe themes or standard plots that have like the styling that you like, and the only thing that you're changing, that you're passing in, is like the column names and the data frame. So here we're making a scatter plot. This is how, this is saving a little bit of typing, but you can imagine if you like really customize this scatter plot, putting it into a function might be worthwhile, because then you can just create your scatter plot with this one line of code instead of retyping this out for every scatter plot that you want, assuming that you want them mostly to look the same. So in this scatter plot function, we're calling Ggplot. We're going to take in data frame as our first function argument. And then our next two function arguments are going to be what column we want mapped to the x-axis and what column we want mapped to the y-axis. These are going to be dropped inside of AES in Ggplot. And you can see what I'm using here is something we've used throughout this entire talk, which again is those curly braces, or the curly operator. We're embracing those column names here. And then we're just saying that we want to do a scatter plot. We're adding GM point. We can add as many layers as we want to customize our Ggplot plot here, but I'm just going to show this simple example just to illustrate that we can do this. So I'm going to run and define this function, and then we can create this plot. It works, and here we can see that here is our plot where we've got height and mass plotted on the x and y axis respectively, and our customization of having an alpha of 0.5 to make it 50% transparent also happened. So yeah, this knowing that, I'd say like the take home message of what I've just shown you here is knowing that you can write functions, and you'll hit this problem with loops too. You can write functions in loops with the Tidyverse functions, and you should, if it makes sense, to dry out your code. What do I mean by like dry out your code? Do not repeat yourself. If you're repeating yourself a lot, you should do something to remove that repetition, because repetition introduces possibilities for errors, and it's also harder to debug. Okay, So we want to remove the repetition from our code where possible by things like functions. And now that you know that there's a problem with unquoted column names, or now you know there's a solution when that happens in the Tidyverse, you should be able to solve that problem yourself and break through that barrier, even without a deep understanding of what is going on underneath and the complexity that the Tidyverse team is really kind of hiding from you by allowing you to use these simple operators. So any general questions before we move on? And maybe we can do 1 or 2 worksheet questions collaboratively, and then we'll stop for Q&A, and I'll leave the worksheet if people want to continue to work on it after the workshop.
I don't see any questions in the chat, so I think everyone
Good. Okay.
is content.
Excellent. So I'm going to go into the worksheet here. And what I will do is I will kind of talk through the question, and then we'll take a break, and people who are interested in working on it themselves can work on themselves for a little bit, and then we'll come back to, I mean, we can all be here, we don't have to like leave or anything, but I'll say like we'll pause for 5 minutes to give this a try, and then after 5 minutes I'll present the solution. Does that sound like a plan?
Yeah, that sounds great. Is there a link to the worksheet? Oh, there we go.
Maybe yeah. So it is inside of the GitHub repository. So if you downloaded the folder or cloned the folder and then opened it up inside of RStudio, sorry, maybe I can be a little bit more helpful in directing it. So once I have the repository open inside RStudio, there's a folder called Worksheet. And then there is this prog-tidyverse worksheet.rmd. So this is what I have just open up here. And apologies if you can hear some noise. My daughter's only 4 and she's playing with my husband right now while I'm giving the talk. So that's the background noise.
No worries. Well, thank you for taking time out of your personal, evenings to come teach.
No problem. No problem. I'm happy to be here. Okay, and there's one extra package that you would need, or you don't necessarily need it, but I'll be using it to demonstrate that the data works. But you could probably use the Star Wars data frame in place of this. So I'm going to load the libraries that we need, and I didn't hide the messages, so that's what all these messages are coming out for. These tests are going to kind of hint to you if you're close to the right solution or not. And if you want to run the test, then you would also need to have, I think, dev tools and the test that package. So sorry, I should have had those things more explicit. Okay, so the first exercise, let me see if I can put this on the visual markdown so it's a little bit easier to read. Okay, go down here. So the first exercise is, I think, something very similar to what we just did in the talk. So I'm going to give, here I give you a get rectangle function, and it doesn't work for unquoted column names. And so we're going to go ahead and try and use the curly operator to embrace the column names so that the function works as expected. So what I've done here, these funny comments is how you write is how you write comments for our packages so that they will automatically become the documentation. So this kind of information is what would become the function docs, and it's just provided to give you some more information. But this is really the issue here. So we have a function. It should take in a data frame. It should take in a row to filter. It should take a column range. The default for this function is everything, but the user could replace this with some other value of the column range to select. And if we, I don't know why it's not letting me run it. Let me see, go away from the visual markdown editor. Oh yeah, the reason it's not letting me run it is, yes, let me explain how this is gonna work. Sorry, my brain is getting a little tired after talking. This is just markdown code. And then you can just copy and paste at least the code part of it and paste your code here. And we want to be able to get this to essentially work. And we're probably going to get an error here. And so we want to fix this function so that we don't get this error here. So I'm going to, I'll hang out here and we'll give maybe like 4 or 5 minutes for folks to give this a try. And yeah, even if you don't have the code downloaded, you can just perhaps like think about what we just went over and look at what's going on here and see if you can guess as to what we should do to solve this code, okay? Solve this problem.
Just a quick note as well. If anybody's having any trouble or they need help with getting the worksheet on their computer, we're more than happy to help with that as well.
And maybe just so I know how people are, progressing and stuff, feel free to just type done in the chat when you finish, if you finish, and then I'll have an idea if some people are done or not.
I'm glad there are more data sets now besides the iris data set and the MT cars to work with.
Yes. No, it's good to have lots of options for data sets. And it's actually one of the maybe one of the hardest thing about I find for creating good data science content for courses is to find an interesting data set and an interesting data set that shows helps you illustrate the points you want to make, has the right kind of data. It can be very challenging, but the Penguins one is really great.
Yeah, this is great to see. I'm in a book club for advanced R. And so I just led one of the discussions for one of the chapters. And for me, everyone else had used empty cars. And I was like, I just care so little about cars. So I just found a data set online that was about dogs and cats that had been lost. And you use that because it was for me more interesting. Yeah. And in the end, I was like, look, now we've found dogs that are adoptable right now. So this is awesome. This is cute. And
then you can add nice cute graphics to your lessons and stuff too. Yeah, it's nice. It's fun. All right, there's a couple of people who are done, and it's been 4 minutes, so I'm gonna go ahead and maybe I can just ask some of the people who are done for some ideas on how to solve this in the chat. Or you can copy and paste your answer into the chat. Great, thank you, Katie. So Katie's solution involves something that we've seen a lot of, which is embracing these unquoted column names. So we have two of them to deal with, one for the filter function and one for the column range function. So let's see if this solves the problem. And there we go. We're able to run our code, use our function, and get back the data frame that we wanted, which was the penguins data frame where the body mass is greater than 3,000 grams, and we're grabbing the columns from species to island, which in this case is just those two column names. Okay, so I also have some tests that I put in my worksheet that let you know if you are on the right track. It's a little bit tricky for these tests to make them perfect for these more kind of complex tasks, but it's possible. Let me see. Yeah, let's give this one a try and see if we can do this together. So why do we need to embrace columns with curly braces or do something that's equivalent when writing functions that wrap the Tidyverse functions when we want to pass them unquoted column names as function name arguments? And let's choose all the answers that we think are correct. So here the test might be helpful, but you want to put them in something like this, like A, and create a character vector to say that those would be the ones. So I'm going to give you folks a few minutes to think about this. Let's say write done in the chat again when you're done, and then I'll ask folks to help me solve this problem. All right, I'll just give folks one more minute to think about this, and then I'll ask for help in the chat. All right, so you can just type the letters in the chat that you think are correct. Great, thanks again, Katie. So we've got B and D. And then I have a little test that hopefully tells us if we got it correct and our test passed. So let's go back and take a look at this. So yeah, we were talking about this earlier, and that the real problem when you're trying to do indirection, so use function arguments to refer to columns in the data frame, is that when you do this, R looks in the global environment for them, but they're not there. And so what we need to do is do something so that it will look in the data mask instead. And that something relates to D here. And I didn't fully explain it in this talk because I think it takes a bit more time, but Yuka, you asked a question about this, and you know what's really happening is that this curly operator needs to unquote and evaluate. It needs to quote the column names to kind of get them in to the function, and then unquote them and evaluate them, not just in the global environment or the function environment, but inside of the data mask environment where R will be able to see the column names. All right. So let's try exercise 3. So this function is called nest and count, and it doesn't work. So our task again is to identify why and fix it so that it works. So we're gonna again copy this text into your code here and take a look. So this function takes a data frame, and it is using we didn't talk about this function, but we're going to create a nested data frame here using the nest function. And to make nest work, you usually group by something first. So this is a column in the data frame that we want to nest by. And then we're going to mutate a particular column. And we're going to be doing so basically, what I'm trying to think about okay, we're counting the number of rows. That's what we're doing. We're using the map function to count the number of rows for each group that we have nested. And where this second thing here is what we're going to call that new column name, okay? So we are going to, let me just take a look at this as well to make sure I'm not missing something. I think I have a typo here, so I'm gonna erase that. It should look something like this actually. So I'll paste this in the chat so that you can easily have access to it. Sorry about that typo. But how we would call this function is call a data frame like the penguins data frame, and species is the column that we want to nest by. So we'd end up with kind of like 3 data frames stacked up in the data frame, and we want to call the new data frame, which is going to be the count of how many rows are in each of these nested data frames, n. So when we run this, there's an error. And even if you don't know how to use map double or nest, you still, from what I talked to you about today, should be able to pick out this error and solve it. So take a few minutes and give that a try. So again, type done if you are able to answer this in the chat when you are done. I'll give another Just a minute or two, just in the interest of time, so we have time for questions and answers after. Okay, just in the interest of time, I'll move along. So does someone in the chat want to give me a hint at what you think we should do to fix this? Right, we should use the Walrus operator. So we are doing some assignment and we're using the embracing symbol on the left-hand side of the equal sign operator. So by adding 1 colon to make this the Walrus operator, we're able to not have a error when we define our function, and then we end up getting these nested data frames. And it's a little, I might actually just show you what this looks like in the console. The visual Markdown doesn't do a great job of showing nested data frames, or at least not the version I have. So we end up having this list column with these nested data frames here. So the Penguins data set itself has, I guess I never showed you folks what it looks like, but the Penguins data frame looks more like this, where we have many species. And so we have, in fact, 3 different species, Adelaide, Gentoo, and Chinstrap. And so what the function that we wrote above does is it group by and nests the data frame by species. So we end up getting a list column that has 3 different data frames in it. And then we used map to go in and count how many rows were in each of these data frames here. But you didn't have to understand nest or map to be able to solve or debug this problem. What the key was here was seeing that we were using the embracing on the left-hand side of the equal sign doing assignment. And so we have to make that work by using the Walrus operator. Now, for the next one, I think I'm just going to live code the answer because I didn't have time to talk about this other thing you can do instead of using tidy evaluation. So sometimes you can do something a little simpler that's called pass the dots in R. And so you can do that to just directly send through whatever the user provides to the function. Just you can imagine it's just like a pipe or some sort of like, I don't know, trap door that sends it directly into the function where you put these dots. And it's pretty interesting and pretty cool. So I'll just show you an example of it here. It doesn't work all the time. There's if you want to like put things in different things in multiple different places, this won't solve your problem. But if you just want to put something in one place, it can be really useful. And you can use it in combination with the curly braces. So here we're going to create a function that's called select and arrange. And this function, let me type a function, is going to take in a data frame. It's going to take in a column name to sort by. We'll be using the arrange function on that. And then we just want to be able to use whatever kind of tidy select syntax that somebody wants to use to select column names. So all we do is just leave dot, 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 dot at the end of our function definition here. And then what we're going to do is we're going to take data, we're going to pipe it into arrange to order the data frame by a particular column, and we're going to do that by sort by. And this is an unquoted column name, so we need to do the double curly braces. And then the last thing I wanted to do is select which columns we're going to use. So we're going to select, and what we're going to do is just basically take whatever the user passes in here. So we can just put dot, dot, dot. And so whatever, thanks RStudio, whatever the last function argument somebody says in their function call will get dropped in here for dot, dot, dot. So let's take a look. I don't know why this is saying, I think I had some copy and paste errors going on in here. This seems like this is not, this shouldn't be here. So let's give this a try. Let's call select and arrange. And we're going to give it the penguins data frame. Let's sort it by body mass in grams. And I have to go up, maybe go down to the console to see body mass in G. Okay, that's the column name I'm going to use here. And we are going to select, let's select island to flipper length. So we'll say island to flipper length in millimeters. And this works, and it's pretty neat and pretty cool that whatever we put in here will get filled in for this dot dot here, and it will get dropped into your function wherever that dot 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 notation calls. And in R, the nomenclature for this is called pass the dots. And it can be really useful. Yeah, I'm not going to go into much further detail in this because we don't have much time left, but it's just it's another thing you can look into if you're interested in learning more or play around with, and can be used in many different situations. So that's all I'm going to do with the worksheet. I'll leave the rest for you to experiment with on your own if you're interested. And I'll stop screen sharing for now, I guess, and see if folks have questions that they'd like to ask.
That was very informative. Thank you so much. Oh, we have a question
No
there.
problem. So Zaid is asking, is it best practice or recommended to use pass the dots? So pass the dots are pretty nice and pretty easy. The reason where you might want to do more than just pass the dots is where you want to put things in different places, right? So pass the dots is going to take that one thing that you put at the end, and it's going to put it wherever you put the dots. The nice thing about the pass the dots is like it can be quite long or complex, and that can be really nice. It will catch all of that. So if you are going to, I think, use select and use commas to separate column names, that should work nicely with pass the dots. And don't feel the need to ask necessarily questions about what I just talked about. I'm happy to talk about R data science outside of tidy evaluation.
I do have a question about this. I don't know exactly what the circumstance is, but say that you are like what your function does both uses tidyverse and non-tidyverse calls and functions within it. What's the best method then to ensure that the column names that you want to pass through get to where it goes? Is it the end quote option or end quote, and then using that where it needs to be and then not, yes, that's, yep.
Yeah, no, that's a good question. It's a pretty hard, I think it's a good question, but it's maybe hard for me to give a general answer. So I feel like strings can be maybe more useful with base R, some base R subsetting of data frames. So if you are mixing a lot of things, I might suggest using asking your user to give you the column names as strings, for example. But so that's one thing to think about. Yeah, with the curly curlies, you don't have a lot of options to do more complex things. It's basically like use that within a tidy evaluation like data mass context, use those curly braces. If you used enquo and bang bang, there are some like more fancy things that you could possibly do with it. So if you need to do more than that, perhaps that might be the way to go. But yeah, it's a great question, but it's a really tricky question. Yeah. And I do agree that from like the user perspective, it would be quite confusing to like have to like give some of the column names as strings and some of them as unquoted column names like that. I would hate to use a function like that, or I would find that very difficult to remember, and I would make a lot of errors. So it would be good to keep it consistent within your function. Yeah, and that's probably also why when somebody asked me earlier, what would I do? Would I keep it as unquoted column names or strings? And I think just based on how I've encountered and used the tidyverse functions in the past, it's mostly been in this like unquoted column names, and I like that. I would keep that feel for my user, and primarily my user is future me most of the time. So yeah.
Thanks.
Sierra, do you feel comfortable asking the question?
Yeah, I can. So first of all, thank you. That was fantastic. I learned a lot. I'm really glad that I
Oh,
came.
great.
I'm only asking this because it was mentioned that you work with Python as well. Are
Mhm.
data variables something that's implemented there? And does it have a structure like this for working with them? I know it's not really analogous because there isn't a tidyverse, but
Mhm. Yeah, you can kind of think of like pandas being pretty close to the tidyverse, and they have functions that map on in a lot of cases to what you see in the tidyverse. But most of and pandas is the library that implements the data frame object in Python. And most of the operations dealing with column names using that, they are all using quoted column names. There is this kind of dot notation you can use in Python. So data frame dot name, which is kind of similar to the $ in R. So you can do that as well. But you see people, so yeah, so both the quoted, like it's a square bracket and then quotes around the column name, or this dot notation without the quotes, but that's more like the $ and not like what's going on in the tidyverse. There's just that one function where I've seen it where it's the query function, and the query function is kind of, yeah, interesting and funny, that it has like a special operator. It's when you want to use this kind of like unquoted column name thing. It's a bit strange. Sorry, I don't have the example at my fingertips for you. But yeah, it's not really the same at all. And the people who come to R and see the tidyverse, who've programmed a lot in other languages, are pretty shocked and befuddled and confused how this can even work. Yeah, so it's pretty cool and special to R, I think. Yeah.
okay, great to know. Thank you.
It's nice to have something to brag about for R when talking to people that
Oh,
use Python.
I think there's lots of things that are great about the R programming language. Yeah. Yeah, we teach both R and Python in the Master Data Science program that I teach in. And I would say that almost everything we teach in the program, including all the machine learning stuff, that you can do equally well in R and Python at this point. Like Python has come leaps and bounds in their data wrangling and data visualization, and R has come leaps and bounds in the machine learning libraries. And it's only like when you're like need to be at the, I don't know, in my opinion, it's only like when you need to be at like the bleeding edge, or like doing some very edge cases, that like you have to use one language versus the other. So yeah, that's my thoughts on it. And it's more about like, you usually don't program in a silo, right? And so it's better to use the language that the people around you are using, as opposed to like write code that nobody around you can read or use or will read or use. So yeah.
What was your first programming language that you've learned?
Oh, the first one that I ever used. So I was very lucky that in high school, there was a lot of programming classes at my high school, which is like a rural high school in Ontario, like not not to be expected, just the teachers there who ended up there, a few of them like to program. So I learned first this Turing programming language, and it's like an educational language. So that was the first one that I learned.
I've never heard of it, so it's interesting.
No, it's on Wikipedia, so it exists. But I know I don't think people use it much these days, or I don't know if they do, but yeah. and it was just for kind of like education. But for data science, I first learned MATLAB. That was the first one, and that was again because of the people around me. And so I had people around me that were using MATLAB, and then I could use it. I learned to use it from their help, and then after that, I kind of hit the wall with MATLAB with statistics, without wanting to like write things from scratch. And so that's when, and data visualization. And so that's when I moved into R. Yeah. And Python's something I learned later for teaching.
I have a slightly tangential question because I follow you on Twitter and have heard of like how you've been marking all of your courses using R, and like being able to see that now kind of in person was really awesome for this section. And yeah, I'm just kind of wondering how well it works in your day-to-day teaching, and how often does that, like, I don't know, breakdown, you probably have perfected it by now, but I don't know, there's always weird things that happen that you don't expect.
Oh, how often does it break down? I don't know if I want to answer that question, but it breaks down quite often, but it depends on like what parts of it. So it's more like the infrastructure breaks down a bit right now, because we're kind of like making the infrastructure up as we go, and yeah, we make mistakes and stuff. But so that's more of like getting the grader to run and return the assignments and all that kind of stuff. The auto grading tool itself is not a tool that we wrote, so we use something called NBGrader that kind of does like the adding up and all that stuff. But like what you saw me run, just those tests, those are used by NBGrader, but you can also use them in your education just to give feedback to people. So if you go to open up the test file in the worksheet folder, they're just tests written in test that, like you would write unit tests for your own research code. And yeah, we've been using them to kind of give hints to tell students whether or not they successfully answered the question. And then you can also write nice little messages using test that, or even your own if statements, and give them hints like, you guessed C, but did you think about this? And so, yeah, it's the students report that they really like having this feedback, especially in like larger courses where grading can take a while, or you don't get a lot of feedback in those courses. So it gives students more feedback. And yeah, it can be the biggest thing that I find that can inhibit learning is if you make a mistake in your tests. And so that you, like, the student has the right answer, but they keep hearing that their test failed. That can be really sad. So we try really hard to proofread, and that's one thing. But then there's some auto grading software that can generate tests based on a type of expected object. So you're expecting a data frame, and then you can give it a data frame and it can write tests based on that. So we're moving towards a system more like that, so we have less human error coming into generating the tests. Yeah.
Awesome, thank you. I think we have some questions. Wendy in the chat asked about further reference to pass the dots.
Oh yeah, I should.
Yeah, Katie linked to Hadley's Advanced R book.
Yes, I'm just trying to think of like where those exist. So there's a talk by Lionel Henry. I'm just Googling it right now about tidy evaluation, where he talks about pass the dots, and it's quite nice. I think it's, no, it's sorry, it's this talk here. I feel like it's this. And Jenny has a talk as well. Sorry, it would take me a few more minutes to find that for you. But there's a talk by Jenny Bryan, as well as a talk by Lionel Henry, where there is some nice slides about pass the dots. Yeah. Sorry that I don't have that reference off the top of my head.
I mean, once you find it, we can post it on our events page as reference.
Oh, okay, good. I didn't know if there's like a way to get information out to the community. Okay, yeah, good. I can do that.
We could do that, yeah. Okay, are there any last questions for Tiffany?
I personally want to ask about how you went from neuroscience to your current role, but maybe that's like too long for this space. But I'm a neuroscience PhD student right now, so I'm always curious. Also 5th year, so like the end is in sight.
Yeah, I can I can try and sum it up very quickly, and that I like teaching a lot. And I was forced to do data analysis and statistics for my research. And so combining those two things kind of like led me down this path. And one organization that I wouldn't be here without is Software Carpentry, or it's now known as the Carpentries. So I became a carpentry instructor. I took a carpentry workshop during my postdoc and then became a carpentry instructor and was very involved in the community and just met so many amazing people, learned so much about data science and learned so much about teaching. And then it has a very strong network as well. So I think part of it is like serendipity of like where people are and who you know. And so Jenny Bryan, as I was getting involved with the carpentries for a while, Jenny Bryan is also a carpentry instructor, and they were starting a master's of data science program up and looking for postdocs. And I was in, I was like right place at right time a little bit, in addition to like doing the things that were kind of like helping prepare me for that path and that transition.
That's cool. I'll check out. I've heard that before, the data carpentries, but I haven't really looked into it, so I will. Thanks.
Yeah, they do like really great and really cool 3-day workshops. And they're like, the idea is that help researchers go from using like point and click software for doing their statistics or graphing to using something like R or Python, and how do you get a graduate student or a postdoc or a PI there in 3 days? Not like completely there, but started. And that's kind of the mandate of their workshops.
Oh, well, that sounds really, really relevant to me.
And I think there's a small community of people here in Vancouver who are software carpentry instructors. I mean, yourself and one person I know, he just moved to Seattle, so we lost him, but still in the area, same time zone. So yeah, I guess, yeah, software carpentries, I want to vouch for them too. They're a great community, like all over the world, operating in different languages now, in Japanese and also Spanish. So it's a huge network, really great group of people. You can get involved with teaching, just participating as a student. You can be involved in curriculum development for your own particular field of expertise. So it's a cool community. And that's how I learned about Tiffany over Twitter. Yeah. Well, thank you so much, Tiffany, for spending the last 2 hours with us. I learned so much from this workshop, and I think everyone did too. And I will share your resource as well as the recording once we have it up online. It'll take a little while, but stay tuned, everyone. And also, we will have another workshop next month by Reiko, who will be teaching us about developing new packages. And she works with the BC Ministry of Health. So hot topic, health, BC, COVID. So there's lots of interesting content coming your way. So stay tuned on the meetup page, and let's give Tiffany a round of applause with your emojis. Thank you, everyone. Thank you.
Thanks so much for having me. I had a great time and great questions, folks. It was really nice.